Okay, I think it's time. So, hello everybody. My name is Ido. I'm with lakeFS. With me is Amit. Hi Amit, how are you?
Hey, Ido, doing good. Thank you.
Fantastic. Just as a few housekeeping rules before we start, we're here today to talk about data access auditing and data lineage with lakeFS and in general. A few housekeeping rules. So this webinar is available in two different places. One is on this Zoom that I'm presenting on, and the second one, we're also streaming this live on LinkedIn. Everybody here is anonymous on the Zoom. And everybody is on mute. If you have any questions, then please feel free to click on the Q&A button on the bottom of your Zoom or post them on LinkedIn. We will answer those questions either live or with written or we'll write answers. Those of you that post into LinkedIn, we have Karen here that's going to help us and repost those. So there's a little bit of a delay with the LinkedIn, but don't worry, we will answer those questions as well. Just keep in mind that if you post a question, then even in Zoom, then your name might appear there, and you can choose to be anonymous or not. Okay, so without further ado, we're here to talk about, like I mentioned before, about data auditing and data usage. So let's start first by talking about Lineage instead of going over this beautiful slide. Amit, you've been doing data engineering stuff for a while now, not to embarrass you, but you have lots of experience here. So can you walk me through a couple of examples where having Lineage for how the data transformed would have been helpful?
Yeah, I think mainly on the troubleshooting side, like if something breaks down in the midway, if I'm running a ETL job, it breaks down in the midway, what happened? I would like to know. So that's where it helps. And also on the compliance side, where did this data come from? What transformation, who changed the data and where it came from? That's also very important for compliance.
I see. Okay, so yeah, there could be many, many reasons for someone to want to understand where the data came from, either because something broke, or because you need to prove something, or because just you want to work in an efficient way, or because many people are using the data, and so on and so forth. And today, obviously, you and I both work at Reverse, the company behind lakeFS, an open source project that we're going to discuss today. I'm going to open a quick poll here because there is a bunch of people on the line with us, and just to understand if anybody here has reviewed or has not reviewed lakeFS before, because if you have not, then if there's a lot of people that never heard of lakeFS, then I'll probably go in a little bit more details. But if lots of you have heard about lakeFS before, then I'll quickly go over some things that might be obvious. So I'll just give everybody just 5 more seconds to answer this very, very, very short single question. Okay, great, thank you. Okay, it looks like we have some sort of a mixed results. So I'll give an overview quickly about what lakeFS is. So basically, lakeFS is here to manage data the same way as we manage code. It sits on top of an object store, and it gives Git capabilities: branch, merge, rollback, commit through an API. So the ecosystem of tools that we have running in our system can either access the object store directly from whatever tools that you're using, or you can go through lakeFS and then get those versioning capabilities, right? And to make the refactor very easy, what we did is, if before we were accessing a collection on a bucket, now we will simply include a name of a branch or a commit identifier. So a name of a branch can be prod, test, dev, main, emit test 1, do feature 3, whatever it is. We can make as many of those as we want. And a commit identifier is a point in time on any branch, right? So production yesterday at 5 p.m. before an ETL ran, or production yesterday at 3 a.m. when you first ingested the data. Obviously, those commits, similar to what you're familiar with Git, are tied to each other. So we have the flow of what commit came after what commit, which can be very useful for Lineage, which is what we're talking about today. These Git actions themselves can be done through an API, can be done through your Python code, through an SDK, through a command line. As you see here, this is a lakeCTL command line that creates a branch out of my production environment and call it my experiment branch. Now, just because there are some people here that are not familiar with lakeFS, the way that lakeFS works is it manages metadata. So every commit in lakeFS is a collection of pointers to objects that sit on top of your managed bucket, meaning the data always sits in place. The data will sit wherever it's sitting now, and a commit will basically be a collection of pointers to that data. And because the object store is immutable, what we do is copy and write. So when a new file is created, the next commit will point to that additional file. But files that did not change, you will have multiple commits pointing to the same physical objects. This design is super helpful because, let's say, for example, I want to create a completely isolated environment of my entire production branch or development branch. I do that without copying any data. It's a metadata only operation. And out of the hundreds of users that we are aware of as an open source solution that use lakeFS, we have users with petabytes of lakes, and this will always be a millisecond operation. And of course, going back in time for the sake of Lineage, for example, is also an operation that doesn't require additional storage, because in fact, what we do is we deduplicate the lake over time, right? You don't have to take, by nature in data lakes, a lot of the files are static, and then a smaller subset of the files change on a regular basis. It's not like we need to take a snapshot of all your files over and over again, the same files, in order to go back in time. So that was just for the sake of those of us that hear about lakeFS for the first time, just like a super brief overview. And today we're going to go through a demo that's going to talk about Lineage and auditing. We have three steps to that demo. One, we're going to install a lakeFS server. A lakeFS server can be spun up in seconds from lakeFS Cloud. You don't have to do. There's no commitment to spinning up a lakeFS server. You just put your name and email, and then we'll spin up an environment for you that you can use. Then we have a Lineage example in a sample repository that Amit is going to use. We're going to open that sample repository, includes everything that we need. There's a Python notebook. There's all the libraries that you need there. And then we're going to run through a data lineage example on that demo. So super easy for anybody that wants to do this on your own. We'll share these examples with you before. But just because we have like 700 different demos with different environments, would be great if you guys take just 10 seconds, 15 seconds, and answer what your environment looks like. Because if we hear that everybody here is on Min.io, then we might show you something a little bit different than if everybody here is on Azure or GCP. Of course, all of those are possible. And similar, a lot of times data lineage is associated with orchestrations as well. So it looks like, okay, it looks like we have majority here on AWS, which is not surprising. And we have all different types of orchestrations. Okay, so without further ado, I think if we can show an AWS demo, Amit, that can be fantastic.
Okay, thank you. Let me share my screen. Okay, let me hide these controls here, Zoom controls, so it's easy to navigate. Okay, as Ido mentioned, we need to sign up for the lakeFS Cloud. lakeFS Cloud is available on AWS, Azure, and GCP, and you can quickly, it's a free to sign up for 30 days free trial. I already signed up. When you sign up, you will receive an email to verify your email address. So you'll receive an email like this. And then once you sign up, verify your email address. I already did, so let me log into my lakeFS Cloud environment. You can log in as an email, or you can use your organization space that you use to sign up. So I'm going to use my organization space and log in. So Okay, so when you log into your lakeFS Cloud admin environment, this is a cloud admin. From here, you can spin up multiple lakeFS environment. By default, when you sign up, we start or provide you or provision a lakeFS environment for you. So you can, it takes about 5-10 seconds to provision it. So once it provisioned, then you just click on this link and it will take you to the lakeFS server. And once you log into that lakeFS server, we also provide a sample repository. We provide, in this case, a bucket also. We provide our own S3 buckets for testing purpose, but you can connect your lakeFS cloud environment to your own bucket also, your own, whether it's on S3 or if you're using Azure or GCS, you can connect to that. But today I'm just going to use the S3 bucket that lakeFS cloud provides. That's what I'm going to use today for this demo. Okay, so that was setting up the lakeFS cloud. The next thing is to clone the sample repository. So let me go to that link. We have multiple sample repositories, but today I'm going to just focus on the data lineage and auditing piece. And here it provides the prerequisite, which is like a running Docker on your local machine. So you can run this sample in a container, and that Docker container includes everything required to run this demo. And here are then you also need the lakeFS server, which we just did on the lakeFS cloud environment. There are certain functionality we are going to use today in the demo, which are available only in lakeFS cloud, like auditing features. They are not available in the open source. And next you do the setup where you git clone this sample repo. I already did clone this, so I already have a samples repo cloned here. And then you go to this particular folder where this data lineage sample is. And then you run this, build the image, Docker image, and run the container. And when you do this for the first time, it might take 5-10 minutes to download all the images, but I did once earlier, so I have all the required images on my laptop. So this was pretty quick. And once you run this, I have this container running, which includes this sample notebook and Python plus Spark, anything required to run this demo. So that was kind of a prerequisite. I went pretty fast on that. I hope I did not miss anything. Either anything you want to add?
No, this is still unrelated to lakeFS. This is just our effort to make it super simple for everybody to set up. So you clone the repo, you run a command. It's literally what's written down here, and then you're ready to get started against your lakeFS server. You can use lakeFS server. You can either spin up also the open source environment on your side, and then you'll be able to do almost everything that we're presenting today, besides the auditing. Or you can spin up lakeFS Cloud, which is like you mentioned, just a very easy way to spin this up. No hassle.
So now my container is ready. So now let's go to my Jupyter Lab UI. So here is a link to go to that. So right now we have disabled the password to log into Jupyter Lab, but in case you want to add the password, you can change that. But here we have this notebook and also all the files or data files required for this sample notebook. Like we are going to use 2 CSV files. That's also included here, as well as anything required to run this notebook. Okay, so this was all the setup. Initially sign up for lakeFS Cloud or install lakeFS open source. Then do the setup part to create this sample container, and then open up this notebook. So let me walk through the use case here. So what we are going to do is we are going to create a simple sample repository, which will have a main production branch. And then we're going to ingest 2 different files, which I mentioned, the 2 CSV files. One is the employees, another one is salaries for those employees. And the best practice in lakeFS is whenever you bring any data, you bring into a separate branch, in a separate ingestion branch. and then you merge into your production. Or in this case, I'm merging into transformation branch, and then after the transformation is done, I'm going to merge into production. The advantage with this approach is if anything goes wrong, you can always roll back the changes. So in between, after every task or every operation, we are going to commit the information. So all these blue boxes are like commits. And if anything goes wrong, you can revert back to any previous commits or any commits you want to roll back. So that's the advantage of utilizing lakeFS. Okay, and once we merge this, then we'll also look into the auditing feature, like who is trying to access the data set. Like if somebody is trying to access the salary files for all the employees, that's how we can show you in the auditing feature, like who is accessing what data, what are they doing with your data sets. Anything else either you want to mention about the use case?
No, and of course, what we see with our customers and users is much more complicated ETLs than this. And it's so easy to go back in time and get this lineage. Here we have a very simple thing, right? We're getting two data sets, we're merging them together, and then we want to see what's the original file that a salary came from, for example. But imagine hundreds of steps in a complicated ETL and the ability to roll back on that. And again, if someone has questions, feel free to post those on the Q&A or post those on LinkedIn, and we'll get those sent to us.
Okay, so let's get started with this notebook. So first thing here, let me increase the size, font size, so people can see. One thing we need to lakeFS credentials to connect to the lakeFS server. It can be open source. In this case, I'm going to use cloud. And so you provide I'm going to set these things as a variable in Python. So the lakeFS endpoint is basically this URL on the top. If you see this one, or if you're running locally in open source, you can get that endpoint. So let me paste this here. Okay, next thing, you need an access key and secret key to connect to the lakeFS server. So let's get that too. So for that, you go to the administration part here, and then you can create your access key. So let's create the access key here. And let's copy this, the access key first. And then I need the secret key. And normally you'll save this access key and secret key somewhere, safe location, because when I close this window, the secret will be gone. Only the access key will be visible. But you can create a new access key if you need and delete the old ones if you forgot the secret key for those. Okay, so far we got your endpoint to connect to lakeFS server and the access and keys. Next thing is to provide the storage to create the repository. I'm going to create a repository for this demo. So, and that requires a storage namespace. As I mentioned earlier, we provide an S3 bucket with this cloud environment, but you can also connect your this lakeFS cloud to your own bucket and then use that as a storage namespace. But I'm going to use this S3 bucket, and what I'll do here, I'll also create a subfolder within that, because let's say if you create multiple repositories, you can put in the different folders. So let's call this Lineage. Okay, so let me set up this. Let me just run these cells and set up these variables. Next thing is the versioning information. I'm going to create the repository with my main as a production branch. Then as I mentioned earlier, I'm going to create two ingestion branches where I'm going to ingest the data, and then merge into transformation branch, run my transformation, where I'm going to partition my data for this certain CSV file. Okay, so set those variables. Next thing is to create the lakeFS client. So we provide a client for Python and other programming language also, but in this case, I'm going to use the lakeFS Python client to interact with the lakeFS. And I'm using those access keys and everything that I set up as a variable initially. Next thing, I'm going to create a repo here. So let's call it maybe Lineage example repo name. Again, this is a variable. You can change whatever repo name you want to call it. Next thing is to create the repository. You can create the repository from the UI if you want to. Just give the repository name and storage namespace. But for this demo, I'm going to create from using the Python API. Again, just calling this create repository, providing the repository name, storage namespace, and my production branch name. Okay, so now if I refresh my UI here, lakeFS, now I should have my Lineage example. And for this, I'm using the bucket provided by lakeFS and just having a subfolder within that. But again, you can connect to your own S3 bucket. Okay, so far I got the repository created. It's empty. Next thing, we are going to bring some data set via ingestion branch. So also set up the Spark context here, create the Spark context. I'm going to use S3A gateway to interact from Spark to lakeFS. But we also provide lakeFS client also. If you want to use lakeFS client, you can use that to interact from Spark to lakeFS. Okay, so next thing is to create the branch. I'm going to create the ingestion branch first branch. You can create the branch from the UI also if you want. You can just go to the branches here tab and then create the branch. In this case, create from the main branch, but you can run from this notebook also. So here I'm going to create the ingestion 1 branch from my production branch. Right now, my production branch is all empty. There is nothing in there. And then I'm going to upload an object. I'm going to upload this CSV employees.csv file, which I set as a variable in the beginning. You can also upload the object from UI. And there are two functionality here, import as well as upload. Import is importing from if you have your existing data set in another S3 bucket, let's say, you can import from there. And when we import, we just import the pointers. We are not copying the data. As Ido mentioned earlier, data stage in place in your S3 bucket, we just create the pointers. So if I import like millions of files, it will take a couple of seconds to just get those metadata or pointers to those files. And there another option is upload object, where you can upload the object or file from your local machine, and that will get uploaded to the S3 bucket, which you use to create this repository. So there are two different concepts, import and upload. Import, if you have existing data in some existing bucket, then you can import and we'll just get the pointers. And if you have some data set locally, you can just upload those, and that will go into the S3 bucket you use to create this repository. Okay, so let me import this data set, and then I'm going to commit. Okay, so this was just importing first CSV file. If I go back here in my UI, and right now I did the upload in this ingestion branch. So if I click on this, I have now this CSV employees.csv file uploaded and committed. Okay. Next, I'm going to upload a second file, which is a salary file, CSV file. But for that, I'm going to create a separate ingestion branch, again, from my main production branch. Again, main is empty right now. I'm going to upload the salaries file now. You already know what's the difference between upload and import. And then next, commit this file also. So if I go into the branches section here, now I have my ingest 2 branch also. And ingest 2 branch have only salary information. The ingest 1 branch has employees data set, and the ingest 2 has salaries data set. And now I'm going to merge both the data set into a transformation branch. So I'm going to create the transformation branch first before I can merge. So let's create the transformation branch. And then I'm going to merge data set ingestion. I merge ingestion branch as well as ingestion branch 2 into transformation branch, where you can run your transformation task. In this case, I'm going to partition my data set. So first I'm going to read this data set using Spark and then create the data frame. So when you read, as I either mentioned earlier, like you specify your repo name, which I set as variable earlier, the branch name. In this case, I'm reading from my transformation branch, and I'm reading that employees file. So this is how the data looks like. And then next, I'm going to read the salaries file just to make sure I have all those data set ready. And next one is I'm going to join these two data frames and merge those. So basically joining on the ID key so I can get all the names, employee names, and the salary along with that. Okay, let me partition. So I'm going to partition this data set by department. While this thing is going on, either you wrote this notebook, so you're much more familiar with this. Anything else, anything I missed, or anything you want to add?
No, this is a very simple notebook. This lists were generated by ChatGPT, asking to generate 2 random lists. So that's how lazy I was with creating this data set.
Cool. So just partition the data. Let me commit so I can show you something from the UI. So let's go to the branches. So now I have my transformation branch where I did partition my data. So transformation branch has both the data set as well as the partition data. Here we have partition by department. So we have engineering data set separate from other departments. Okay, next. Now I'm going to promote all these changes into production. So when we promote, it's atomic promotion. What that means is all the data changes that happen, like in this case, we got 2 data files, we ran some transformation, but in real life scenario, you might have multiple thousands of files coming in through your ETL process. You might have run a lot of transformation tasks. So when you merge into production, everything merges into production instantaneously in one single command. And it's all atomic promotion. So all that data set is instantaneously available to your users. Okay, so now, so this was all kind of creating the repository, running the ETL job. Now the fun part for this is to show the lineage information. So if I go into, let's say, my main branch, let's say production branch, and I want to see how the data, these different partitions data came through. We have a functionality called blame, which is similar to, like, if you're familiar with the Git, where you can see where this data came from. So in this case, it came from this commit ID, and I committed this like just 2 minutes ago. And also when we commit, I forgot to mention this, at that time of commit, you can include the metadata. In this case, it can be a code version, like you want to point it to us. If you have your ETL code, you can point it to that. And any kind of metadata you can include here for lineage purpose, tracking purpose. So, and then from here, you can go to this particular commit ID and also see what else it came, what other data set came through this particular commit ID. Like in this case, we just had data set for different departments, partition by departments, but you can go to the parent and also get all the data set. In this case, like salaries also came from the previous commit. So you get full lineage. So in every step, as you saw, we made a commit, so you can see what changes are happening. And anytime if you want, you can roll back the changes also. So this is from the UI, but you can get the same information from the notebook also. I'll just quickly run. I'll not go through in detail here because you already know how it looks in the UI. Okay, so we have, I think, only 2 minutes left. So the first part was the lineage. Next one is the auditing. So for auditing, I'm going to, go ahead.
Yeah. I think the just to be sensitive everybody's time, the second half of this is auditing. Maybe just run it, just let it run for a second. You guys can open the notebook and look at it. What we're doing right now is basically creating a user that's an engineer, and we're going to have that engineer, as you can see, reading the data, the salaries data of the finance department. And if anybody wants more details about that, that's actually the previous webinar that we did, the role-based access control. But I think the main reason to show that here is to talk also about auditing, which is, Am I showing the right screen? Yes.
Yep.
Which is once we've done that, then we have also the ability to go in look in lakeFS Cloud, and for example, look at all the engineer one user successful actions that he ran against finance, and see that that person at some point actually ran that query. Audit feature is not available in open source. That's a question that we got. No, audit feature is not available at open source. This is the first and only feature, actually. Actually, there's two things that are not available in open source in what we saw. One is creating a detailed user, like Orbit, like creating an engineering one user that has only specific abilities to read specific repositories, not available. And the second one is the audit itself. Both these things are not available in the open source solution. Other than that, everything that we showed here today is available in open source. We have more examples like the ability to track and lineage changes across medallion kind of infrastructure, right? If you have like a bronze, silver, and gold, and you want them to run on separate infrastructure as well, that's something else that we have demos and instruction and examples for that we can review in future solutions. The idea is at the end that you save on storage, you increase your efficiency, and you can recover from production. To answer that question that someone asked, we have on our website, with hooks, can we work around to get lineage? I'm not sure. There's an anonymous question that says, with hooks, can we work around to get lineage? lakeFS has hooks and has the ability to do that. Lineage is available on the open source also. I'm not sure what the question is.
Yeah.
I mean, do you understand what the question is?
Yeah, with the hooks, if you want, you can call that API call, make an API call to get the commit or the information and the lineage information using the APIs.
Okay, so for those of you who are not familiar with lakeFS, hooks is the ability to run code before or after Git actions, like before a commit, after a merge, before a branch, and you can actually choose to fail also. Like you can do a quality check before a merge before you promote data to production, then fail like a CI/CD for your data kind of thing. Again, lakeFS is a core. It's an open core open core project, meaning the functionality at scale is available, and then enterprise features like auditing, like rollbacks, access control, are paid features that are available either in an enterprise solution or with lakeFS Cloud. We'll send an email with some next steps. We have a super responsive community Slack that will love for anybody here to join and ask questions. Last questions from us today is just to know if this was helpful. So if this is helpful, if this is something that you want to see more of in the future from us, then we know that we can generate more content like this to help everybody. Wow, a lot of yeses. So I'm happy that this was helpful. I'll wait 5 more seconds to get more. Okay, fantastic. One more question. Let's see that question. These slides available. So we will share the recording with everybody who attended today over emails. So you'll have those slides. And if anybody is interested in something specific, feel free to respond. Happy to share the slides and do anything that and help anybody understand lakeFS a little bit better. Okay, Amit, thank you so much.
Thank you. Thanks for your time too.